ali eu te aviso, ok?
Tá.
Ok, abriu.
Okay, good morning, good afternoon. We have today the pleasure to have with us the Professor Elisabetta Dotto from the Istituto Nazionale di Astrofisica, the Osservatorio di Roma, and to give her a seminar on the NEOROCKS project. And we present you a brief resume of her CV, but I will do it in Portuguese for our who is listening through the YouTube. Bom, como eu disse, a professora Elisabetta Dotto, ela obteve o doutorado em 1991 na Universidade de Roma. Depois fez o PhD, né, no Observatório de Padova, Universidade de Padova, em 94, com um estágio de um ano em Paris. Depois teve pós-doc também no Observatório de Paris, Meudon Paris, e desde 1999 é pesquisadora, hoje pesquisadora sênior, do INAF, né, que é o Instituto Nacional de Astrofísica, na Itália, e primeiro foi sediada no Osservatorio di Torino e a partir de 2017, a partir de 99, a Roma, a partir de 2000, hoje em dia é do Observatório de Roma. Tá? Ela trabalha essencialmente desde seu doutorado, que foi quando eu conheci ela, quando ela estava em Paris, eu também estava em Paris naquele momento. Ela trabalha com a caracterização física das propriedades físicas de pequenos corpos do Sistema Solar, em particular os objetos em órbitas próximas da Terra, aquelas que podem causar algum risco para a Terra. Tá? E também ela está muito envolvida em missões espaciais aos pequenos corpos, entre eles a Osiris-Rex, a missão DART, é o team leader do Lycia Cube, que é um mini satélite, um cube satellite, que vai estar auxiliando a missão da DART da NASA. E, então, hoje, ela é coordenadora, atualmente é coordenadora do projeto NEOROCKS, um projeto da Comunidade Europeia, do Horizon 2000, e ela vai falar hoje para a gente um pouquinho sobre esse projeto que ela coordena. Tem mais de 300 artigos publicados sobre pequenos corpos, então é realmente uma pessoa que sabe do que está falando. Por favor, please, Elisabetta, I hope I have not said anything wrong, but you have the screen, you have the floor to give your seminar. Thank you very much for accepting giving this seminar to us.
Thank you to you, Daniela, for having invited me to present NEOROCKS. I share my screen to present you. Okay, can you see my screen?
Yes.
Okay, thank you very much. So really, many thanks to the organizers for having invited me to present NEOROCKS, the NEO Rapid Observation, Characterization and Key Simulations. NEOROCKS is a collaborative research European project that has been approved in the framework of the Horizon 2020 work program. We answered to this call SU Space 2019, advanced the research in near Earth objects and new payload technologies for planetary defense, in particular to address the topic C, improvement of our knowledge of the physical characteristics of the NEO population. Here we have our timeline. NEOROCKS started on January 2020 and will end on June 2023. So NEOROCKS addresses the challenge of improving our knowledge on the physical characterization of near-Earth objects and of the implications for their origin and evolution, as well as for planetary defense. This goal is achieved by linking up the expertise in performing small body astronomical observations and the related modeling needed to derive dynamical and physical properties of NEOs to the pragmatic approach of planetary defense. Therefore, our team gathers together research centers, academies, and private sector, acting in Italy, France, UK, Czech Republic, Spain, Romania, and Poland. Here we have the list of the official partners, but we have agreements and collaborations with colleagues of other countries and other institutions. And I like very much to quote our collaboration with the Osservatorio Nazionale di Rio de Janeiro and Daniela Lazzaro in particular. But why we study small bodies? Because they are witnesses of the early solar system. Here I have put a sketch of the planetary formation. At the beginning, our disk was composed by dust and gas. And then planetesimals started to accumulate to form planets. Then giant planets migrated from the original position, and here we have the solar system today, 8 large planets with a lot of small bodies. So, small bodies contain a record of the complex chemical and of the physical processes that occurred in the early solar system. And they are the leftover of the planetesimals which formed the planets. And for this reason, it's important that we study them to have information about the primordial bodies and the primordial processes. In particular, primitive asteroids are the most probable source of prebiotic material, which was delivered on the Earth, and started the processes which triggered the occurrence of life on our planet. We see here that isotopic ratio measurements, as well as dynamical simulations, point towards a major delivery by water-rich and organic-rich primitive asteroids on the Earth. But why we study NEO? Okay, they are, of course, small bodies, so they are the building blocks, the remnants of the building blocks of the planets and of the solar system, but they are the closest to the Earth. So it's easier in some way to study small bodies, to have space missions, and it's very important because they are very relevant to investigate the origin of prebiotic material on the early Earth. In fact, we have meteorites. We know that carbonaceous meteorites contain macromolecular carbon, biomolecules, hydrocarbons, nanoglobules. So it's evident that their parent body, and NEOs among them, contains this molecule and perhaps more other compounds relevant in astrobiology. Moreover, NEOs are studied as water mineral resources, and of course, they constitute a potential threat for our planet, so they are relevant for planetary defense. So far, we know about 26,000 objects with a discovery rate of about 6 objects per night. And mostly of the new discovered objects are small. We can see here in this plot, the blue part, and these are the newly discovered objects, which in most cases are very small. Nevertheless, the number of objects with known surface composition, with known physical properties decreases dramatically for fainter magnitudes. In particular, our knowledge of the physical characterization of potentially hazardous objects and small bodies passing close or colliding with the Earth is so far very poor. So the NEOROCKS challenge is improving the present knowledge on the physical properties of NEOs, and NEOROCKS proposes an innovative approach focused on performing high-quality physical observations and foster the related data reduction, investigating the strong relationship between the orbit determination of newly discovered objects and the quick execution of follow-up observations in order to face the threat posed by the imminent impactors, profiting of the European industrial expertise in ongoing space situational awareness initiatives to plan and execute breakthrough experiments foreseeing the remote tasking of highly automatized robotic telescopes in order to provide a proof of concept rapid response system. This topic is covered mainly by Demos, Stein, and guarantee extremely high standard in the space dissemination through the involvement at agency level of a data center facility, which is the Space Science Data Center of the Italian Space Agency, which is already operating in European and international context. In our activity, we are assisted by a scientific advisory panel and a security advisory board, composed by prominent exponents of the international NEO community. And the role of the scientific advisory panel is to supervise our activities, given their advice on the project workflow and on possible improvements, while the role of the Security Advisory Board is mainly focused to review the project deliverables and assess whether they include any security-sensitive information, and eventually propose measures for preventing the misuse of such information. This is mainly focused on the study of potential impact objects. And so in the case we discover a very hazardous object, the Security Advisory Board helps us in preventing the misuse of such information in public outreach mainly. And here we have the NEOROCKS work package breakdown. Our activity is structured in 6 different working packages. We have, of course, the project coordination and management, the education and outreach, observations and data analysis, orbit characterization, data management, and international cooperation. All the observational data, together with the orbit characterization, are addressed to the working package 5 data management, which interfaces with the working package 6 international cooperation. The idea is to have an efficient use of existing telescopes, radars, and data process capabilities, perform high-quality physical observations and calculation, fostering international cooperation on follow-up observations of potentially hazardous objects, and develop methods for the rapid estimation of an orbit of an object and characterization of its physical and dynamical properties. So let's start with the working package 3, which is focused on observations and data analysis. We have different tasks, and each task is led by one of our partners. So we have the first one, rotation shape binaries. So this is mainly focused on the acquisition and analysis of light curves, and is led by our colleagues in Czech Republic. Then we have the task 2, reflectance spectroscopy. So the idea is to observe NEOs in visible and near-infrared reflectance spectroscopy in order to retrieve the surface composition mainly. And this activity is led by us, INAF Observatory of Roma. Then we have the spectrophotometric colors, once again to study, to retrieve the surface composition of a large number of objects, and this activity is led by the Observatory of Paris. Then we have polarimetric properties. So the idea is to carry out polarimetric observations to retrieve the polarimetric properties, and so to retrieve the physical properties of the surface of the observed bodies. And this activity is led by the Observatory of Turin in Italy. Then we have the observational support to the Arecibo planetary radar program. And this activity is led by the Istituto Astrofisica de Canaria. After the Arecibo collapse, which occurred on December 2020, our partners in Canary Island focused their activity on the targets already included in the Arecibo archive, and with good signal-to-noise ratio. Then we have the task 6, cometary-like activity. The idea is to look for activity detection and investigate and understand how much water is buried in primitive asteroids. And this activity is in comets, of course. This activity is led by the University of Edinburgh. And then we have data mining, so the idea of the exploitation of all the data so far included in archives, and this activity is led by the Observatoire de la Côte d'Azur. Unfortunately, on 2020, so during the first year of NEOROCKS, we had a lot of problems due to the COVID-19 pandemic. The telescopes were closed, and we started working at home. Of course, the working package 3, observations and data analysis, was the most penalized for COVID-19 in the framework of this project. Since the beginning of 2021, the situation returned more and more normal. Telescopes reopened, and here I have reported just a list of targets that have been observed by the different partners. Sorry, here we have a list of observations performed at the Asiago telescope in Italy for spectroscopy. Here we have the granted time at the Telescopio Nazionale Galileo. Here a list of objects already observed in 2018 and 19, and also something observed more recently that has been now under analysis for what concern polarimetric observations. Here we have light curves carried out in La Silla, Chile, in order to analyze and study binary objects. Then we have photometric colors acquired by the Observatory of Paris and other colleagues in Spain, and some work about data mining, something about the taxonomy from SkyMapper. And here we have an example of the results. We have some spectra from Italian and Spanish partners. Then here we have an object, 1998 OR2, which has been observed by Arecibo in April 2020, and then observed in photometry and spectroscopy. So here we have the light curve with a special feature which seems to be due to the crater that all these features actually that Arecibo have seen. And here we have the spectrum. Another very interesting object is 2020 AZ2. Our colleagues in Czech Republic observed these objects, discovered the satellite, and determined the light curve. And this is one of the smallest known binaries. We have that the primary body has a diameter of 140 kilometers, while the secondary body is just 80 meters large. Of course, the observational campaign is ongoing, as these are really the first preliminary results. So we will present you more results in 1 year and a half. Our partner, SpaceDis, is responsible for the working package 4, orbit characterization. SpaceDis deals with imminent impactors identification, providing a tool to the observers in order to have a better orbit determination. And this is very important for the follow-up observations to obtain the physical observations. SpaceDis works also on recovery and discovery apparition. In particular, they implemented a new service for the generation of lists of target for the observers. This service includes generation of ephemerides of all NEOs for the next year on a daily basis, parsing of the ephemerides to determine which are visible within the time frame of 1 year, and the possibility for users to set some filters for their own purposes. Here we have an example of the filters that an observer can put, and here we have the output table, which is sortable and can be downloaded for local use. This is a very useful service because it's not a priority list, but is a target opportunity list, which has been thought for observers who need to program their observing schedule on a longer term. Since, as an example, they are writing a proposal, and so they need to list all visible NEOs within the year. On the contrary, the priority list is thought for observers who want to prepare in real time the nightly program and list targets visible at that moment according to a priority value determined by an algorithm. So both these services are offered by our partner SpaceDis. Working package 5, the activity of the working package 5 is focused on data hosting and dissemination. And the role of this working package is twofold: guarantee the necessary exchange of information between the working package working on observations and the working package working on ephemerides generation and target list generation, and storing and disseminating the related data products. These goals are achieved through the realization of a project technical web portal, whose functionalities actually are progressively implemented during the project. The web portal initially encompasses only the basic functionalities needed to immediately support the observational activity, like priority list, target opportunity list, and data repository. And a requirement definition activity is now started in order to evolve the technical portal towards its final configuration. So, full set of observation support tools and physical characterization database. At the end of the project, this technical web portal will be migrated into the Space Science Data Center at the Italian Space Agency, and the Italian Space Agency will maintain and update this web portal well beyond the end of the project NEOROCKS. This is a service that will be maintained for the whole community. So this is the first release of the internal first release of the technical web portal. The important thing is it will include orbital catalog, ephemerides, and physical properties. And this is a service that will be maintained after the end of NEOROCKS, and that will be reachable for the whole community. So all our colleagues can use this web portal. The very important thing is that we included also physical properties. So it's not just as the JPL who reports orbital catalog and ephemerides, but also physical properties. This is because so far we do not have a updated catalog and database of the physical properties. Here on the right, we have the present status for physical properties. We had EARN here, which was a first database maintained by Gerard Hahn, which is not anymore maintained nor updated. Another European project before NEOROCKS, NeoShield and NeoShield 2 tried to create a database, but actually it was limited to the partners of the project and is not anymore updated. So in the framework of NEOROCKS, we want to create a physical properties database hosting different data products resulting from different sources of new observations. Of course, this will ensure an efficient data products dissemination and will ensure short, long-term data storage and availability. Therefore, the NEOROCKS technical web portal, we have a user-friendly interface, and the users will be able to customize, as an example, a query to search all the observations made so far, as an example, for a given object. So this is a very useful system that will allow us to have a very good exploitation of all the data so far published. So this technical web portal will include, of course, data acquired for and during the NEOROCKS project, but also data imported from existing archives, EARN first of all, but also for future archive. This means that new data will be uploaded by the partner of NEOROCKS during the NEOROCKS project, but also by external partners. Every observer worldwide who wants to share their already published observations with the whole community can update their results on this web portal in order to facilitate the data exploitation And this is also in the future after the end of NEOROCKS, and this service will be maintained for the worldwide community. NEOROCKS includes also the study of synergies with international endeavors. The situation in Europe is a bit crazy at that moment. We have, of course, national agencies, as an example, the Italian Space Agency, the CNES for France, etc. We have the European Space Agency, which is not the Space Agency of Europe, because the members of the European Space Agency are not the same of the European Union. So the European Space Agency is a space agency of a consortium of states, while the European Union Agency for Space Program is newly founded and is more focused on services. But this year, on June, the European Union, represented by the European Commission, and the European Space Agency signed an agreement on the implementation of EU SPA, which is the new European Union Space Program, and Horizon Europe, or the program, under the Financial Framework Partnership Agreement. So NEOROCKS is witnessing a great event with the entry into force of the new EU space program and of the EU ESA contribution agreement under this Financial Framework Partnership Agreement. And during the presentation made by the European Space Agency in occasion of this agreement, NEOROCKS has been quoted several times as an European NEO catalog and physical properties database, and in some sense as a precursor of the networking of member states' assets and physical properties observations. So this is the international situation for what concerns Europe. And for this reason, NEOROCKS includes the study of synergies with international endeavors. We are probing the engagement of European and international partners in a proactive contribution to the detection and observations of NEOs. We are analyzing the European and international initiatives and the potential collaborations at an institutional level in order to identify the opportunities of data sharing with other projects. Of course, the NEO Coordination Center of the European Space Agency, but also the Center for NEO Studies of the NASA, and UNOOSA, which is the United Nations Office for Outer Space Affairs, of course, the European Union, and others. And the idea is to highlight the possibility of continuing further extending the network of observational assets to the contribution to the NEO physical properties database and the rapid response system scenario established during the project. Last but not least, as all the projects funded by the European community, NEOROCKS must have a well-defined dissemination and public outreach activity. The goal of the working package 2 is to provide targeted, non-specialist information to the wide audience in a strategic and effective manner of the actions carried out during the project. So the target of this activity is composed by university students, school children and teachers, and wide public and civil society. And here we have a list of the project material, such as leaflet, poster, and roll-up. We also publish our activity, and here we have some partners' activity. We have on the web several papers and articles about NEOROCKS, And we also organized events dedicated to children. This was in the occasion of the last Asteroid Day. And we prepared 3 videos on NEOS, asteroids, names, and telescopes. And here we have 3 of our partners, Sara Banchi, Ettore Perozzi, and Julia De Leon. We have also a project website updated with news related to space and asteroids, with articles and videos shared by the partners, and with information and presentation. And we have also Facebook and Twitter accounts. Okay, this is very important for the public outreach. So a lot of activity are devoted to public outreach and education. We are also preparing the newsletter that will be published, a sort of a journal devoted to the public, wider public. And I mean, all these activities are in the project website, neorocks.eu. And this is my last slide. I was more rapid than I was supposed. I'm sorry about that. If you have any question, please tell me now.
Thank you very much, Elisabetta. It was great. It's okay. A lot of work, a lot of missions and objectives, but a lot of people also. And imagine a lot of money also.
Yes, the total amount was 2 million euros. This is the grant we obtained, and we are a lot of partners, of course. And the most important thing is that what we want to, I mean, the idea of these European projects is to do something, but to offer a service. And this means that something that will continue the activity well beyond the end of the project. And this is the reason why we spend so much efforts on the technical web portal, which is a service that all the community will use if they want beyond the end of the project.
But this is something that is interesting to me, as you well know, because we are collaborating on some projects.
Of course.
So we have data, and the access to this technical portal will be only of the members.
No. Okay,
now.
For instance, yes, because we are working on that. So, for instance, is a facility oriented to the partners of NEOROCKS. But at the end of the project, this facility will be moved the Space Science Data Center at the Italian Space Agency and maintained for the community. So every observer who has physical observations, that means likers, spectra, etc., can upload and on the contrary is kindly requested to upload the already published, of course, observations in order to give this kind of service to the whole community.
Yeah, but this will be only after the end of the project.
we are starting now with our observations and ongoing during the next 1 year will be opened to the whole community. So, I mean, for instance, is in progress. So, I mean, we had the first release, and we are checking this technical web portal. We are putting our data, and we are defining all the criteria and all the requirements in order to have a very efficient system. So, in 1 year, this will begin available for the whole community. So all the observers worldwide can check the technical web portal to understand, to see if some observations are available for a given target. And once they have new observations, they can upload these observations on the web portal.
So yeah, Elisabetta, great talk. I have a question. How will be the participation of NEOROCKS with the upcoming DART mission? You mentioned you are the PI of some satellite, right? Some probe.
For LICIACube? No, can you repeat the question?
For the DART mission.
Yes, for DART mission, I'm involved as the science team leader of LICIACube. LICIACube is a CubeSat, something very small, 10 per 20 per 30 centimeters, who will fly with DART and will be released 10 days before the DART impact on the Dimorphos, the satellite of Didymos, and will witness the impact and will carry out physical observations of the system, Didymos and Dimorphos. So these are two different activities, actually, but of course the data that we'll have about Didymos and Dimorphos will be included in the database of the technical web portal of NEOROCKS. Everything which is about NEOS can be included in the technical web portal of NEOROCKS, of course.
Right. And what instruments do you plan to have on this CubeSat? A camera, something else?
We have two payloads, actually, a small a camera, a wide-angle camera, which is used also for navigation, and a narrow-angle camera, which is equipped with a Bayer-Partel filter. So we will have 3 different colors, RGB. So in practice, we have 2 cameras.
Right. So fantastic. Thanks.
You're welcome.
George,
yeah,
are you seeing if there are questions in the
right.
YouTube? Yes,
so I can make them. So Felipe Monteiro is asking, Dr. Elisabetta, thank you for the nice seminar. I would like to know if the determination of physical properties of very small NEOs, diameters less than 200 meters, for example, is an important goal of NEOROCKS.
Yes, it is. Of course, it's very important. And for this reason, actually, we have we started this synergy between dynamical aspects and physical observations, because generally the asteroids, the NEOs, are discovered when they are brighter. This means that if we do not have follow-up observations just after the discovery, we risk to lose the objects, because in the next opposition they will be typically fainter. This means that it's very important to carry out physical observations of newly discovered objects to try to have a physical information of the smallest bodies. And this is very important. It's very important for several reasons. It's very important because actually we do not have so much small, dark, primitive NEOs, and this is because there is a bias effect on the observation. So with NEOROCKS, we can look for small, faint, that means dark, that means primitive NEOs. For this reason, we tried to put together dynamics and physical observations. So really, we are trying to observe the smallest possible NEOs.
Right. So you mentioned several types of observations. I don't remember if you mentioned albedos, something to get the albedo of the objects.
Okay, yes, of course. The albedo, okay, we can retrieve albedos from polarimetric observations, and we can have an idea of the albedos from spectroscopic and spectrophotometric observations. Because we are not in this way, we do not have a measurement of the albedo, but we can retrieve the taxonomic classification, and so to have an idea of which is the mean albedo of each observed objects.
All right. So I don't see if we have more questions. Do you have any questions, Daniela?
I stopped to share my screen. That's okay for you?
That's okay.
Yeah.
So I see you better. Oh.
I don't know, there is nobody who has questions. I have a lot of questions, but this is more because we are collaborating, and so it's more technical questions than really scientific questions regarding the observation. Because at the beginning, when the NEOROCKS started, Elisabetta showed that the OASI is, it was even one of the smaller photographs of the telescope.
Yeah, of course.
It's listed as a rapid response telescope for the NEOROCKS, because we are always open to work with Marco Micheli and so on. When there are interesting objects, we always try to observe them, beside the project at the SUA telescope.
Yes, one of the most useful service given offered by NEOROCKS is this target, the priority list and the target opportunity list. So we can find quite rapidly the list of objects that is the case to observe.
Yeah.
And
for example, the SUAR observation, they are made in collaboration with not with NEOROCKS formally. It's not a NEOROCKS
unfortunately,
but it is with the people from Elisabetta. Elisabetta is in the project. Davide, Simone.
Yeah.
When we have a time for observation, a few days before, we ask them to have the list of the new objects to be observed at SUA, so to perform exactly this, the observation of the smallest ones, because they are recently discovered, and if we take time, then we will not be able to observe it. So we are using one of the results already of the NEOROCKS in finding the priority list in the sense of the small objects. So we are it's more a formal thing.
Yes, and for us is a great and for us is a great opportunity to collaborate also with people, not European people. For us, it's very important to have collaborations worldwide. So I'm very happy to work with Daniela and the Osservatorio Nazionale di Rio de Janeiro.
Okay, so there is no more questions from the YouTube, because I cannot.
No questions.
The only. Okay, so it's time. It has come time to say goodbye. But first of all, to say thank you very much, Elisabetta, for your time, for having prepared and to have talked with us with so great details about this project that I am very happy to see that it will produce something that is beyond the Europe. That is something that is always very difficult for us, because the projects normally are very closed in Europe. The horizon with 2000 is open, but it's not so much open. It's difficult. So now we have 2 students of us that are in the NEO project. They are with fellowship from the NEOROCKS. One is Pedro, that you said, Pedro Haselman, that is starting in Rome. And we have Isa Medeiros, that is at the IAC.
Yes.
And she was also a student from the...
Great.
Yeah, so we are having profit of the NEOROCKS with our students. I hope in some moment the Europe also will allow to have postdoc here.
Yes, yes.
But this is a more difficult point. But
we hope so, Daniela. We hope so.
We hope so. So thank you very, very much. And it was very great to see you.
Thank you to you. Great. There's been a great opportunity for me. So thank you very much. I hope to see you soon in person.
And I hope to, and we invite you to visit the observatory sometimes. It's been already many times that you have been there.
Yeah. I will come with a very pleasure.
Okay.
Thank you very much.
Bye-bye. Bye-bye.
Ciao. Thank you.